You may not know this, but there are actually a lot of careers out there and actually a lot of studies that center around how to order things in lines. Now, this may not seem apparent right off the bat, but if you consider some things like Disneyland, for instance. Now, in Disneyland, we have a situation where you have hundreds and thousands of people who are lining up for rides, and there's a limited number of rides, but a lot of people. And a lot of times, those lineups can last for a long time. And so, what Disneyland has to do is they have to find a way to get people to stay in the lines, right? When a person commits to a line, basically they're making a commitment to ride the ride. But if a person decides that the lineup is too long or it's unpleasant or whatever, then they will leave the line and they'll break their commitment. And what we call that in the ordering world is reneging, right? So reneging is when a person or an item leaves the queue or the line that it had promised to be in. So reneging is when a person leaves the line that they initially committed to. All right. I may have spelled reneging wrong, but I don't think so. All right. So what we want to do is we want to try and make it so people don't renege. Another thing also, but like, what if it's not with people though? Well, sometimes, for instance, if we're working in a factory, you could have products going through the product line, and the way that we actually process products actually matters to how products can be moved efficiently through through the production process. Also, if you have, like, for instance, a number of jobs, like, for instance, let's say as a student, you have a whole ton of homework, like you've got 20 assignments that you need to do, and they all have different due dates. Well, what is the way that you can order those assignments so that you can get the most done without losing the fewest on late marks, assuming there are late marks, right? So there's a ton of different studies on how to do this. This happens all the time in the business world. For instance, you could have a print shop, right, where the print shop might have so many orders that they can't possibly get them all done on time, and they're going to have to be late on a few of the orders. So how do they decide which orders come first and which ones don't, right? So, and what order to do them in? Well, there's actually a lot of study and work around that, and there's actually people's jobs to order those things. So today we're going to look at two different ways of ordering those things. Now, the first is actually called a stack. Now, a stack is basically like a stack of things. Now, I know I just used the word in the definition, okay, but consider it like almost like a stack of plates. Okay, so let's change that. So basically like a pile of plates. So when you add a plate, okay, where does it go? Right? Well, the answer is it goes to the top of the stack. Right? So you just put the plate onto the top. And when you take a plate from the stack, where does it come from? So when you take a plate away, where does it come from? Right? Well, the answer to that is that it comes also from the top. So basically, a stack has a configuration where the first item in is the last item out. Okay, and what that means is that, let's say I am stacking plates, right? The first plate I put down into the stack, let's say I put another one and another one and another one, and I have 10 plates. Well, where is the first plate? Well, it's on the very bottom of the stack. And what that causes is that that item cannot come out of the list until every other item is removed. So what we do is we refer to that as FILO, or last in, first out, LIFO. Okay, and what that means is that the last item that goes in is the first one to come out. And there are actually a lot of different applications for stacks that you probably have not really considered. Most people don't really think about when we use stacks, and we'll get to that in a minute. Okay, I'll throw down some examples later here. Now, by contrast, we have a queue. Now, a queue is basically like a lineup in a store. All right, so what we have is when you add an item to the line, a person, let's say, right, where does it go? Right, well, basically it goes to the back. Right, that's how we can kind of think of that. And what happens, right, if you take, when a person wants to come out? So when you take an item from the line, where does it come from? Right? Well, if it was a stack, it would also come from the back, but in this case, it comes from the front. Now, this kind of makes sense because if your cafeteria lineup, for instance, was done in a stack formation, basically what would happen is that let's say you had a person line up and then another person line and another, and you had 10 people in line. Well, where would the cashier, right, or let's say the server, take the next customer? Well, if they took them from the back of the line, then the first person, the person at the beginning of the line, who was the first one there, would renege. They would say, well, I'm not staying here because I have to wait until everyone else is served. So what they would do is they would renege and leave the line and then try and come back in from the back. And then the next person, who is now at the front of the line, would also renege and so on and so forth. And no one would want to stand in the front of the line. So what you'll have there is basically an untenable situation, a situation that just can't work. So what we do is we call this configuration. We call this first in, first out. All right, also referred to as FIFO. So first in, first out, or LILO, last in, last out. Right, so if you're the last one in the line, you're the last one out of the line. The first one in the line is the first one out. And this is probably the one where you can probably think of the most examples. So typical examples would be like cafeteria lineup. Right, other ones would be like, I don't know, like music requests or something like that. Like basically where there's every task that you're asked to do, you just do that task and then you just do the next one and the next one and the next one and stuff like that. All right. Now, what about a stack though? Right. So stacks are a little tougher because we typically don't really think of this. Like obviously we can use the example that I gave, the cafeteria plates, right? But what else? Well, there's actually a number of things that you can look at, and I'll give you two examples here. The first one is that we can actually do a stack where we can look at the undo button. All right, so what will happen is like when you're working with something and you basically the computer is recording everything you do. And then what happens is when you press undo, it takes something, basically one of the actions that you've committed off of the stack. So it will take off the thing that you just did, right? So what it's doing is it's as you're doing things, it's adding them to this list of things that you've done, and then you undo it, it takes the thing off the top, right? It doesn't take the first thing you did, it just takes the last thing, which is exactly the undo button. Another item is the browser's back button, right? So let's say I'm surfing the internet and I'm looking at a number of different websites, and let's say I'm shopping around or something like that. And then what happens is that when I choose to go back, well, where does it go back to? Well, it goes back to the previous website. So what happens is the computer records the websites that you visited and it puts them into a stack. And then you're currently on the last item that you visited, but when you go back to the one previous to that and not the first item that you visited. So that's an example of using a stack. Now, there are some other applications for stacks and queues, right? So for instance, in a queue, what we can do is we can actually use this for what's called a breadth first search, right? So sometimes when you're searching for paths, what you can do is you can make a list of pathways of steps to explore. And basically what you want to do is you want to say, okay, let's say I take one step forward and that leads to two separate other paths that I can follow, right? And then from there, like each one of those might lead to two others, and they could be joined up and stuff like that. It could be like a different web of pathways. Well, what we can do is we can actually use a queue system to start exploring, saying like, okay, look at this path, and then look at this path and look at this path, and we just want to look at them in order. And instead of trying to look at every possibility, which will take forever, then what we can do is just build a queue and just look at the steps one at a time and build it up, and then basically work until we find a solution. If you are interested in breadth first search and seeing an example of it, I'll put a link in the description of this video to my video on breadth first search. And if you are writing the CCC, that's the Waterloo Computer Programming Competition, or if you're writing the USACO or something like that, understanding the breadth first search is a must. They basically have it on every single exam. Okay, so breadth first search is a really important one, right? Now, what about a stack though? Okay, so for a stack, there is something where basically you can do like guessing and testing, right? Explorations. So in the guessing and testing exploration is, let's say for instance, I'm doing something like a Sudoku solver. And what I have is a Sudoku puzzle and I just want to try and guess my way through it. Well, what I can do is I can make a guess. And so what I do is I record the state of the puzzle into a stack. And so I record the state and then I make the guess, and then I continue solving as I can. And then once I get stuck, what I do is I make another guess. But before I make the guess, I record the state back into another item in the stack. Now, eventually, I'm probably going to guess wrong. So how do I know that I've guessed wrong? Well, I will know I've guessed wrong because there will be a logical inconsistency in the puzzle, like one of the cells won't have any potentials. Now, what do I do? Well, if you've guessed wrong, then what you have to do is revert back to the previous state in the stack. So let's take a look at this. So let me just make a little bit of room here. Okay, and we'll just shrink this down a bit. Okay, so let's take a look using this. So let's say each one of these nodes represents the Sudoku puzzle. So what I can do is, let's say I'm solving it and I get to a point where I need to make a guess. Well, what I do is I make a record and I put it into a stack like this, and this will be number 1. Okay, and then let's say I'm continuing solving and I come across another part where I have to guess. Well, then what I do is I say, okay, well, let's copy the whole puzzle again and put in a number 2. And then let's say we're continuing on and I have to make a third guess, right? So I'm going to copy the puzzle again into a stack. Now, what's going to happen here is that eventually I'm going to make, let's say number 3, I do number 3 and I realize there's a logical inconsistency in the puzzle. And what that would mean is that I can't, like that number 3, the guess 3 is wrong. So what I have to do is go back to guess 2. So you can see what will happen here is that currently I'm on guess 3 and I realize that guess 3 was wrong. So I can go back to guess 2, to the previous state. I would not go back to guess 1 because guess 1 could be correct, right? And then what will happen is that guess 2 would make a new guess 3, right? And then what will happen from there is I just continue on and it just keeps going, either adding items to the stack or taking them away and reverting back until it actually finds a solution. And that's basically how you can use stacks to create basically a guessing and testing algorithm to guess your way through solutions. So anyways, there's actually lots of different applications of stacks and queues. Some of the ones that we have worked on in class, for instance, is like the quicksort. Well, what happens with the quicksort is, and basically with any recursion, is you form a stack. So you have one method that runs, and then what will happen is that method will call itself. Well, that method actually creates a stack of methods. So what happens is stack one create or method one creates method two creates method three creates method four. But when they're resolved, the resolution process goes instead of so their creation is 1, 2, 3, 4, but the resolution is 4, 3, 2, 1. So it's actually the one that resolves first is the last one that was run, which is your last in, first out. Right, so that's basically an example of how we've done this. Another one that we work on in my class is that when we do the brute force solution to the Knight's Tour, right? Again, what we're doing is we're exploring paths, and when we're exploring paths, we're basically guessing and testing different pathways to get solutions to the Knight's Tour. And so what happens is that you are guessing one path, and that knight moves to the second path and adds it to the stack. That knight, the new knight, moves to another spot and adds it to the stack. And then what happens is if you get a knight that cannot move anywhere, it reverts back to the previous knight, so it pulls itself off of the stack. And so what we have is essentially a whole stack situation. Right? So you can see actually in coding, we use stacks quite a bit. It's just you may not realize it explicitly. Anyways, that's the basics of stacks and queues. If you have any questions, please put them in the comments. And definitely follow the link if you're interested in breadth first search. If you are interested in writing any competitions, you must understand how to do the breadth first search. Anyways, that's it for now. Thanks for watching, and I'll see you in the next video.